Again, because you mentioned this boundaryless universe that he proposes, where if you were to reduce the universe backwards in time down, rather than come to a point, it would kind of come to a curve.
Right.
Kind of like a badminton birdie.
That's right.
Why is that a more appealing model to him? It seems to, I mean, what's the difference between a cone and a point, you know?
Well, the difference would be that the cone has an edge to that geometrical structure, whereas the badminton birdie doesn't have an edge. You can go right on through the South Pole and up the other side. And so as a result, the laws of physics don't break down anywhere in the model. But I think, as you're sensing, the model, in fact, involves an absolute beginning to time in the universe just as much as the standard model does. It just doesn't begin at a point of infinite density, space-time curvature, temperature, and so forth. The South Pole that is featured in the model is like any other point in space-time rather than being a singular point. But it's still the beginning of the universe. And I did think that one of the most interesting features of this book that was new is the interpretation that they lend to the Hartle-Hawking no-boundary proposal. Namely, they treat the South Pole in the model as the beginning of time, and the lines of latitude that would go north from the South Pole up the structure, they treat those as a measure of time, of the duration of the universe, so that the universe and time itself has a beginning at the South Pole in the model, which is, of course, the second premise of the Kalam cosmological argument, that the universe began to exist. So rather than present this imaginary time regime that's pictured at the beginning of the model as timeless or just existing in a sort of tenseless way, they present this in the grand design as the absolute beginning of time. And Hawking says this has the advantage of avoiding the otherwise awkward question, what was there before the beginning? Because on this model, time begins at the South Pole, and therefore there is no before, and therefore it's meaningless to ask what was there before the Big Bang. Now, what he doesn't seem to appreciate is that while that does effectively remove that question, the standard model with the singularity does exactly the same thing. It is meaningless to ask what took place before the singularity, because the singularity represents the boundary point of space and time, and therefore it's meaningless to ask what there was before. So the theist who believes that God created the universe will say, with respect at least to physical time, that while God is causally prior to the universe, he's not temporally prior to the universe. Traditionally, theologians have interpreted God to be timeless, and therefore he would not exist temporally prior or chronologically prior to the beginning. The answer to the question, what was there before the Big Bang, in a chronological sense, is nothing. There wasn't anything. But God is causally prior to the Big Bang, but not temporally prior.
Okay.
So I found the book actually to be very supportive of theism and of natural theology, at least with respect to the cosmological argument.
The Kalam in particular, then.